Number 1, state the frequency and period of the following sinusoidal functions. So, the big idea is frequency and period are related. They're related by this idea, BP equals 2 pi. As the frequency increases, the period decreases, and as the period increases, the frequency decreases. As one goes up, the other has to go down, because when I multiply them together, I always have to get 2 pi. The b value, frequency represents b, is the number in front of x. So the frequency is 8. To find the period of this function, the period tells me how long does it take to get through one full cycle. How long does it take to get through one full cycle? So 8p equals 2 pi. So p equals 2 pi divided by 8, which is better known as pi over 4. So, apparently, it takes pi over 4 units to get through one full cycle of this cosine curve. Y equals 5 cosine of 2 pi over 7x plus 3. Well, the b value, the number in front of x, is the frequency. So the frequency is 2 pi over 7. How do I find the period? The period is BP equals 2 pi. B times P equals 2 pi. Multiply both sides by 7. 2 pi P equals 14 pi. Pi's divide out. 2p equals 14, p equals 7. This function has a period of 7 units. That means it takes 7 units to get through one entire cycle of that cosine curve. You should quickly say that cosine curve has an amplitude of 5 and a midline of y equals 3 as well. And finally, what is the frequency? The frequency is the number in front of x. The frequency is 4/3, which makes the period BP equals 2 pi multiplied by 3 divide by 4. P equals 3 pi over 2. So it takes 3 pi over 2 units to get through one full cycle of that cosine curve. That's a quick thing that you need to be able to do. If I give you frequency, you need to be able to get the period. A sine curve has a period of 2 pi over 7. Determine the frequency of this function. So, I'm telling you that p equals 2 pi over 7. It takes that many units, that number, to get through one full sine curve. Well, I know BP equals 2 pi times by 7, b times 2 pi equals 14 pi. We just solved this equation. B equals 7. The frequency is 7. So if I was to write the sine curve, it would be a 7 in front of x, because that is the b value. That's the frequency. So if I give you the period, you can also find the b value. A child is on a swing. It takes the child 2 minutes to swing back and forth 30 times. State the period and frequency of the sinusoidal function that can be used to model the child's height over t minutes. It makes sense that this is a sine curve. The child starts low, swings high, and it just keeps going on and on and on. And apparently, this happens 30 times in 2 minutes. Notice that we're using t minutes, so I don't need to change any units here. 2 minutes is good to use. 30 times in 2 minutes. I want to know, how long does it take to get through one full curve? So, it took 2 minutes to get through 30. How many does it take to get through one curve? Well, 2 minutes out of 30 times gives me 1 over 15. So 1 over 15, it takes 1 over 15 minutes to get through one time. So the period is the number 1 over 15. It takes 1 over 15 minutes to get through one cycle. Well, BP equals 2 pi. B times 1/15 equals 2 pi. B equals 2 times, multiply both sides by 15, 30 pi. So the frequency value is 30 pi. A final note on this one. Why did we do something like this later on? Lessons 12 and 13 are all about modeling, and we can eventually write the equation of the sine function with more information. And you're going to have to find the b value. You're going to have to find the period in b value. So that's why we're going to do these types of modeling questions and practice for that. Number 4, write the equation of a sine function that has an amplitude of 2, a period of pi over 2, and a midline of y equals -3. So we have an amplitude of 2. So y equals 2 sine of, I'll deal with that later. My midline's -3, so I need to shift down 3. What number goes in front of x? It is not pi over 2. That is the frequency. That's the b value there. So b times pi over 2 has to give me 2 pi. No idea where that line came from. Multiply both sides by 2. B pi equals 4 pi. B equals 4. So the magic number that goes in front of x is 4. This is the equation of the sine curve that has these desired requirements. You could also put a -2 in front, because that doesn't change the amplitude. That just reflects the sine curve about the midline. So instead of starting up from the y-axis, instead of increasing from the y-axis, it's going to decrease as you go past the y-axis. Number 5, sketch one cycle of the function from above. Okay, we had an amplitude of, let's go with +2. Let's make our life easy. Sketch it here. I'll plot the points over there. It's a positive sine curve. It goes up 2 from the midline. I have a midline of -3. It's the first thing I'm going to go draw. -3 is my midline. That's where I'm starting. I have an amplitude of 2, which means go up 2 units from that to -1 and down 2 units from that. -5. How long does it take to get through one full cycle? They told me that. That's pi over 2 there. So I'm going to plot my 5 points. I'm going to plot my midline, max, midline, min, midline. I'm going to plot those 5 points and relabel the x-axis so that final point is pi over 2. So midline, max, midline, min, midline. So here's one cycle of that curve that we're discussing here, where this 4 units over is really a pi over 2. It's not 4. I relabeled it pi over 2. This is the graph of sketch one cycle. We sketched one cycle. So that's the graph of our function, y equals 2 sine of 4x minus 3.